Good afternoon, and thank you for taking the time to watch this presentation. My name is Supandi, and my partner's name is Eifel Linggar Navara. And today I will be presenting a project entitled Leveraging Pre-trained Self-Supervised Learning Models for Low-Resource Multimodal Text and Speech Sentiment Analysis. Uh, this is these are the authors of our project. And then in the following presentation, I will explain the background of the project. In today's digital era, people frequently express their opinions about products and services through various and online platforms. This massive volume of public feedback is valuable for evaluating and improving products. Sentiment analysis is a key tool used to mine these opinions and understands public sentiment. Multi-sentiment analysis has shown great potential in education, healthcare, recommendation system, and human-computer interaction. Despite its benefit, multimodal sentiment analysis face several challenges, such as small and imbalanced dataset, noisy inputs in real-world setting, and high computational demands of deep learning fusion techniques. And the next one for the literature review, which contains three authors. The first one uses text and audio modality, which they did not specify the fusion technique, and the contribution of their study is bimodal text plus acoustic feature improve sentiment classification over unimodality. And the second one, they use text plus audio and visual modality and hybrid fusion technique, which contains of early and late fusion, and their contribution is multi-level fusion with granularity improves performance by 1.3%, and their study use EMOCA dataset. For the third one, uh, they use text and audio modality and use feature concatenation, which is an early fusion technique, and their contribution for their work is achieving 72.15% accuracy using transfer learning and fusion. And the goals of our works is to leverage pre-trained self-supervised model, which utilize BERT for the text and fact for speech to extract rich generalizable feature with minimal labeled data. And the second one, implement a simple yet robust fusion strategy. Apply element-wise addition for modality fusion to maintain modularity, robustness, and computational efficiency. And the third one of our goals is to develop a lightweight and effective multimodal sentiment analysis model, which design a sentiment analysis system that works efficiently in low resource setting using text and speech modality only. This is our methodology workflow of our model, which contains of data collection, exploratory data analysis, preprocessing, text and speech, extract embedding, word and wave to fact, and fusion element-wise, MHA, LSTM, and for the evaluation in in the ending of our workflow. This is our methodology which we use melt dataset for this study. This study utilized the multimodal emotion lines dataset, which uh, this dataset is a publicly available dataset with 13,000 rows of utterance. Each u- each utterance in the dataset is annotated with seven emotions and three sentiment labels that are established for multimodal emotion recognition and sentiment analysis. The map dataset contains dialogues from the French TV series annotated with both textual and audio information. And the next one is for explore- exploratory and data analysis, which contains several features. The feature that we C is the number of utterance, which contain 9,989 in the train dataset and 1,000 in dev dataset, uh, 2,000 and 2,610 in the test dataset, which indicates the dataset size. This is relatively small, which is crucial when justifying the use of pre-trained model and lightweight architecture. And the next feature is average and max utterance length, which useful to determine input sequence length, especially for models like BERT. The short average length may benefit transformer-based model. And for the data preprocessing, we use we use tokenize using BERT tokenizer, fixed input length, which use 128 tokens, and the outputs is input IDs and attention mask for text preprocessing. And for the audio preprocessing, we use loaded as 1D waveform at 16 kilohertz and mono channel. And the audio will be normalized between -1 and 1. Uh, the output is the raw input for wave to fact.
Okay, for the next session, we will be focusing on the architecture that our model use, the results, the way we evaluate our model, and then lastly, we will talk about the conclusion. First part, we will talk about our model architecture. Our model use BERT encoder for the text input, wave-to-fact encoder for the audio input. These two output will be then fused with element-wise addition, and then we will be using multi-head attention, LSTM, and fully connected layer to do the sentiment classification. Next. Next is our training configuration. We use Adam optimizer, learning rate of 0.00001, batch size of 8, and 5 epochs. And we use the default dropout, which is 0.1. And then for the evaluation metrics, we use the following key evaluation metrics, which is accuracy, precision, recall F1 score, and confusion metrics. And here is our confusion metrics on the classes. As you can see, next. Okay, the next one is our performance on the sentiment classes. As you can see, for the highest F1 score, we reach 0.76. For the recall, we reach 0.76 and the precision 0.75. Next, this is a comparison of our single modality and multimodal. As we can see, the accuracy is improved by a bit between the use of single modality and multimodality. As we can see here, the text unimodality have 67.43%, and for our multimodal model, we have 67.66%. For our future works and conclusion, for future works, we will try to improve visual feature extraction. We can focus on facial regions, and then we can try to replace BERT with Roberta for better text encoding. And then for the conclusion, based on our research, we find that text remains the dominant modality, but audio enhance emotional nuance recognition. However, this doesn't really apply to every case. There are some cases where audio doesn't really enhance emotional nuance, but most of the time, it does. And then for the multimodal model, performs slightly better than unimodal baselines. Audio input adds emotional depth, though text remains dominant. And then we confirm that light fusion plus sequence modeling is effective, even in low research settings with an accuracy of 67.66%. That's all for our presentation. Thanks for tuning in. Thank you.